Okay, today we're going to talk about 3 by 3 systems, which means 3 equations with 3 variables. Step 1, when you have 3 equations and 3 variables, what you want to do is use elimination to reduce the system from 3 variables to from 3 variables and 3 equations to 2 variables and 2 equations. Now to do that, we're going to have to figure out, if we're going to get it down to just 2 variables, you're going to have to eliminate 1 variable, right? So we need to eliminate 1 variable from all equations. Now there's a simple procedure to do that. What we're going to do is to use elimination, so we need to add 2 pairs of equations. Since we have 3 equations, we need to add 2 at a time, so that means we're going to do it twice. Let me show you what I mean. It'll be easier when you see it. Okay, so let's say I have 3x plus y minus 2z equals negative 8. And then I have 2x minus y plus 4z equals 18. And then we have 5x plus 2y minus z equals negative 1. So in step 1, I need to figure out 1 variable that we want to get rid of, and we're going to eliminate it from everybody. But we do it in a two-step process. So we look at equations 1, 2, and 3. Which variable looks like a good target? Well, if I look through here, x has 3, 2, and 5. Those are a lot of different coefficients. Here we have 1, negative 1, and 2. Ooh, that one looks really nice. Z could work as well, but I like the fact that we only have to really deal with 1 coefficient here. So let's try to get rid of good old y. So what we're going to do is we're going to eliminate y from 2 different pairs. We've got to have 1 pair over here and 1 pair over here. All right, so a pair of equations. Which one pair looks good to start with? Ooh, I really like equation 1 and equation 2 because I don't think I'm going to have to do anything to them. Equation 1 is 3x plus y minus 2z equals negative 8. And then we have 2x minus y plus 4z equals 18. I'm going to add those 2 equations together. 3x plus 2x is going to give me 5x. Y and a negative y does eliminate. That's good. Negative 2z plus 4z is going to give me 2z equals, and that's a 10. Now let's take another pair. We can't use the same ones. We need to get 3 involved. So let me go ahead and write down 3. I know that's going to be one I want. 3 is 5x plus 2y minus z equals negative 1. Again, I'm trying to get rid of y. So if this one's 2y, I'd like the other one to be negative 2y. So let's look back up here. Ooh, equation 2. Equation 2, all I'd have to do is multiply by 2, and I'd get something nice, right? So if I multiply equation 2 by 2, I get 4x minus 2y plus 8z equals 2 times 18 is 36. And now we add. 4x plus 5x is 9x. The y's do go away. 8z and a negative z is going to give me 7z equals, and that's going to be a 35. So now, you'll see that we have 2 new equations. So let's give them new numbers. That would be, I guess, equation 4 and equation 5. In this new set, we have a brand new system made up of 2 equations and 2 variables. So step 2 is to solve the newly created system. And you can solve it by any means. You could do substitution, you could graph it. These, with all these coefficients, it looks like it should be a good elimination one. Which variables should I eliminate, though? Let's look at this. We've got a 5 and a 9. Got 2 and 7. I'm thinking the 2 and 7 might be a good mix. Whoops, sorry. So, maybe I should go with trying to make them be 14 and negative 14. All right. So, to do that, we're going to be eliminating z. To do that, let's see. I would need to multiply this one by 7 times 7. And multiply this one by, oh, how about negative 2? Sound good? All right. So 7 times 5x is going to give me 35x. 7 times 2z is going to give me 14z. 7 times 10 is going to give me 70. Negative 2 times 9 is negative 18x. Negative 2 times 7 is going to give me a negative 14z. And then negative 2 times 35 is going to give me a negative 70. And then we add. 35x and a negative 18x is going to give me 17x. The z's eliminate. And then I have 70 minus 70, which is 0. Divide both sides by 17, and I get x is 0. Don't freak out just because you get a fraction or if you get 0 as an answer. Those are perfectly good numbers. I don't know why people think that they're bad numbers. They're fine. Leave it. All right. Now, we're almost done. Believe it or not, in that one nice step, we are so much closer to being at the end. Now, step 3, plug back in to find the other variables. We have x. Now we've got to go back in and find everything else. Hey, equation 4 and equation 5 look like good choices to find z. So let me take, how about equation 4? Equation 4 is 5x plus 2z equals 10. I'm going to plug in x is 0, so 5 times 0 plus 2z equals 10. 5 times 0 is 0, so 2z equals 10, z equals 5. Now I've got x, and I've got z. Gosh, I need y. Now 4 and 5 didn't have a y, so let's go back to the originals. Ooh, 1 has a y. Equation 1 was 3x plus y minus 2z equals negative 8. Let's plug in everything we know, and I'm going to bring the camera down for this. We know x is 0. We know z is 5. 3 times 0 is 0, so y. And I get negative 10 equals negative 8. Add 10 to both sides, so y equals 2. Now, just like when you have an answer, when you had 2 equations and 2 variables, and you just wrote it x comma y, our solution here is going to be that set of coordinate points, but this time it's 3. And believe it or not, we do x, y, z, alphabetical order. So our solution is going to be 0, 2, 5.